Alright, so review from grade 11. If you're solving an inequality, first of all, just solve it like it was an equal sign. So if this was an equal sign, I would probably move the 9 over and get x squared equals 16. And then when you square root both sides, you get x is plus or minus 4. That's the places where they're equal. Now what we want to try to find are the places where x squared plus 9 is less than or equal to 25. So first of all, can you tell me a point that works and a point that doesn't work? One doesn't work, because if you put in 1 squared plus 9 is 10, and 10 is not less than 25? I think 10 is less than 20. 1 works. Perfect. We wanted to find one that worked and one that didn't. So your first guess was guaranteed to work, no matter what. 1 works. Is there a number that doesn't work? 5. If you put in 5, 5 squared is 25 plus 9 is 34, sorry. 34 is not less than. So we know that the number 1 is good, but the number 5 is bad. The method for finding all of the ones that work, like 0 works. 3 works. 4 does too, it's where it's equal, right? So if we find out where it's equal, we can set up our x-axis and put our number line on here and put the points where it works. And you might remember that sometimes you did open circles and sometimes you filled them in. Since there's the equal sign there, we filled in those points to say those ones are included. Now, since you found out that 1 works, that makes this entire section true. And since we found out that 5 doesn't work, that makes this entire section false. And we're going to find, if you plug in -5, this is also false. So your solution is that it's true when x is between -4 and 4, or you could write it in interval notation from -4 to 4. So how do we solve inequalities? We solve like normal, as if it was an equal sign. Set up our number line. You'll notice in the number line on the second one, you're going to have the open circles because there's no equal sign. So if I solve this one like normal equal to 0, this factors nicely to x plus 3 and x minus 2. So x is equal to -3 and x is equal to 2. Those are the places on my number line where it's equal, but this time I'm going to put open circles because it was just a greater than symbol. Next, we test some points. Let's find a point that works. Like, what's a number between -3 and 2 that would be easy to do mental math? 1 or 0. 0 would probably be the easiest, right? So if I plug in 0, is -6 bigger than 0? No. So this section will be false. Plug in 3. 3 squared is 9. 9 plus 3 is 12. 12 minus 6 is 6. Is 6 bigger than 0? Yes. True. Plug in something less than -4. I mean less than -3, like -4. -4 squared would be positive 16. Minus 4 is 12. Minus 6 is 6. This works as well. So now our solution is x can be less than but not equal to -3, or x can be bigger than but not equal to 2. In interval notation, this would look like -infinity to -3, round bracket because it's not included, and then we use a big U for or, and then 2 to infinity also with round brackets because it's not included. So there's a little review of grade 11. This is going to come up because we are going to have to figure out domains and range of composite functions, and some of those composite functions, like in the construct the understanding, are going to have square roots. So first of all, they want to graph both of those, and they want to graph, oh my goodness, we have lots of graphs on the same grid. So we'll color code this. Do you remember the two techniques for graphing square roots? One of them was using transformations. If you use transformations, you would have to remember this is the same as negative x plus 3. And in transformations, you'd see a horizontal reflection and a horizontal translation. So it has to be in factored form. You'd have to factor out the negative. And so this graph with transformations would be a horizontal reflection and then move 3 to the right. If you graph this using chapter 2, we learned a whole new technique for graphing any square root. Graphing any square root, it said, first, graph the inside. And I'm going to just graph the inside, negative x plus 3, with the dotted line in blue. Would you agree that that's negative x plus 3? And then, in chapter 2, we said wherever it was 0 and wherever it was 1, those 2 points would stay the same. Any other nice points? Well, here it's 4, so it's going to be 2. And now I'm going to erase that dotted line so this graph is going to get too busy otherwise. Can you see that that's the same as the square root graph? Flipped horizontally and moved 3 to the right. So we have 2 ways to graph that first one. I think the second way, because you don't have to remember the factored form, which you always forget anyways, is probably easy. Next, we're going to graph a parabola moved down 1 unit. So here is x squared minus 1. The domain of f of x is that x is less than or equal to 3. And the domain of g of x was everything. That's your domain. Range, y was bigger than or equal to 0, and range was bigger than or equal to 1 for the green one. We're going to complete the table now. So g of x, that was our green graph. I'll put these values in green. Here you would get 8. Here you would get 3, 0, negative 1, 0, 3, and 8 when plugging in those numbers. Now f of g of x is the composition functions. Means first you would do g of x where we got 8, and now 8 goes into f. So I'm going to do these in purple, because this is going to be our new graph. If I plug in 8, 3 minus 8 will give me a negative square root. It'll give me negative square root of 5, which is not possible. If I plug in 3, I get 0. If I plug in 0, I get the square root of 3. I plug in negative 1, I get the square root of 4, which is 2. If I plug in 0, you already know that, square root of 3. This is 0, and this one again will be not possible. So I'm going to plug those points in. I've got negative 2 comma 0. When x is negative 1, I get the square root of 3. When x is 0, I get 2. And I get the square root of 3 again. And I get 0 again. So it looks like this is our purple graph, and its domain only works between negative 2 and 2, and its range goes from 0 to 2. Did the blue graph and the green graph give us any hints of what the purple graph was going to be? You want to say yes, don't you? because usually when the teacher says, is there any hints from the other graphs? Usually the answer is yes, and then you have to find them, right? In this case, I think the answer is no. There's like nothing from the first graphs really helped us with the composition of the graphs. And so we're going to find out that when you have the composition of functions, this method of finding points is great to find some points, but is not as going to be as helpful as finding the explicit equation. So right, it says here, how's the domain related to the domain and range? Not at all. That sucks. So if you knew the original domains, does it help you with the new one? No. If you knew the original ranges, does it help you with the new one? No. So what we're going to find is we are going to find that we will want to write an explicit equation for y equals f of g of x. So if I had y equals f of g of x, first of all, I know that g of x is given to me to be x squared minus 1. Right? Because g of x, well, I should write in the color it was. G of x was the green one. It was x squared minus 1. And f of x, the blue one, was the square root of 3 minus x. These were your two machines. When you have the composition of functions, it says x is first going into g. And the function g says whatever you put in gets squared minus 1. Right? Yesterday we had fun throwing Mahad into the machines. And then we realized that was not a good result. Next, what happens is the x squared minus 1 now goes into f. What does f do? It says whatever you throw in, do 3 minus that and then square root it. So this is going to equal square root of 3 minus, and then brackets, we're throwing in x squared minus 1. If I simplify that, I get negative x squared plus 4. And this will actually be the easiest way to graph this. How do we graph the square root of negative x plus 4? And this is one thing I really like about this last unit. This last unit really reviews our very first unit. It reviews chapter 2. There's a whole bunch of units that it reviews. How would I graph that? Well, first of all, I would graph the inside. The inside, and I'll graph it with the dotted line, is a parabola that's going down. Has x-intercepts at 2, 0 and negative 2, 0. And I'm graphing the square root. That's chapter 2. When you graph a square root of any graph, you find out where it's equal to 0 and where the y values are 1. Then between 0 and 1, it's going to be slightly above. And then after, it's going to be below. Square root of 4 is 2, so I would know that's a point. And there's that same graph that we got from all of those table of values. But now I know that it's right. And I can get my domain and range from my graph. But this is where the quadratic inequalities that we started with, you know in a square root, you know that the inside has to be greater than or equal to 0. Right? So first of all, we start by just solving this. When is it equal? So if I move the x squared over, I would get x squared equals 4. It's equal at plus or minus 2. Draw my number line, and because of the equal sign, these ones are included. I like making the circles extra big because there's something fun about coloring in the middle. It's like, ooh, I just want to color for a while. So if you make them bigger, you get to color for longer. It's more fun. Next, if you plugged in 0, Is 4 greater than or equal to 0? This is true. If you plug in 3, 3 squared is 9. It's not negative 3 squared. If you plug in the 3, order of operations say only the x is squared. And then you multiply by a negative. So 3 squared is 9 times a negative. Negative 9 plus 4 is negative 5. This is false. Same thing, negative 3. Negative 3 squared will be positive 9 times the negative up front will be negative 9 plus 4 is negative, which is false. So now I can tell from here that my domain is negative 2 to 2 using the math from grade 11. That's where the solving a quadratic inequality comes in. But they're not always with square roots. Sometimes they're easier, like example 1. No square roots. This usually means your life is easy. So again, I'm going to color code f of x in green, g of x in blue. State the domain and range of each function. Sketch the graph of the composite function below, and then state the domain and range of the composite function. So dot number 1, domain for my green one is everything. Range is everything. Maybe in your head, you're like, x plus 1, y-intercept of 1. There's my first graph in green. Draw a quick sketch. Drawing that sketch, it's easy to see domain and range is everything. From the blue one, maybe I draw a quick sketch of that. That's a parabola that's going down and shifted up 4 units. Here's my blue graph. Its domain is also everything. Its range was y is less than or equal to 4. Now to sketch this graph, we're going to find the explicit equation first. So what does that mean? Well, g of x was 4 minus x squared. That was the blue function. When you put x into g of x, out would come 4 minus x squared. So I can replace, and I'll put a little blue box around this. So what am I doing? I'm saying this g of x is equal to this, so I can just replace that. Make sense? And now, this 4 minus x squared is going into the function f. What does the machine f do? It says whatever you put in, add 1 to it. So if I put 4 minus x squared in, I'm going to get 4 minus x squared, and then I'm going to add 1 to it. And this simplifies nicely. We'll put the negative x squared, 4 plus 1 is 5. If you have the simplified equation, that makes graphing so much easier. So now, 1, 2, 3, 4, 5. I would have a parabola. I'll graph this one in purple. Parabola that's flipped down. And now, with that graph, it's easy to see the domain of this one is also everything, but my range is that y is less than or equal to 5. So if you can find the explicit equation, it will turn out usually to be something that you know how to graph, and if you know how to graph it, then it's going to be easy to find its domain and range. So we're going to do the same thing with part B. part B was y equals f of x. Well, f of x, that was your green function. And f of x was just equal to x plus 1. Because the f function says, whatever you plug in, add 1 to it. And so when you have f of x, that's just the formula. You're putting in an x again. And so you're going to get an x plus 1. And now, you're plugging in an x plus 1. So the f function says whatever you put in, oh, I put in an x plus 1, just add 1 to it. And now I get x plus 2, which is just a straight line. I'll graph it in light blue. Positive slope. And the domain and range is everything. Yes. So for the composition of functions, what we wrote here, finding the explicit equation first will make everything else easy. If you try to figure out what the graph is from the original ones, they're actually not that helpful. Questions for practice on this one? You can circle question number